Ganymede is the largest moon of Jupiter. It's bigger than Mercury. It is also to explore the secrets of the evolution of the solar system and the protection of human potential resources in the future. Despite this, detected that it has not been stepped on its surface yet. Investigate the reason. Is it because the journey to Ganymede is so difficult? Ganymede, the largest moon in the solar system. Approximately 5,068 kilometers in diameter. Not only is the moon larger than the Earth, it's even bigger than Mercury. Its sheer size in Jupiter's orbit is striking. This moon with planets and masses causes lower densities. Surface gravity is less than that of Mercury. The wooden sweater and the moon. Its geological structure is complex, fused with ice and rain rocks. A lush plain, ravines and mountains, recorded a turbulent geological history in the 1970s. As the new Wind and Voyager probes passed by the moon, the images they captured of impact craters and structures, revealing its immense geological wealth, helps us gain a deeper understanding of the formation of natural satellites and the entire solar system. Its Pioneer and Voyager missions did not focus on Ganymede. Its main goal is to explore gas giants. But with the analysis of Ganymede data collected by these missions, scientists' interests began to shift. Ganymede has the only magnetic field of any moon in the solar system. This may be caused by the opposite of its core metal ice shell. Inspired great interest among scientists and explorers. Between 1995 and 2000, the Galileo spacecraft made 6 close leaps over Ganymede. Discovered that he has a magnetic field independent of Jupiter. The discovery shocked astronomers, because it was previously thought that natural satellites could not generate magnetic fields like the Earth. Ganymede's magnetic field is unique, because he formed in Jupiter's magnetosphere, a micromagnetosphere. It's the only moon in the solar system that does this. This means that Ganymede is protected by a double magnetosphere. This causes the radiation level at the surface to be extremely low, become a place where it is possible to actually live. So astronomers use the Hubble telescope to take a much more detailed look at Ganymede. These observations confirm the laser phenomenon of Ganymede. Tired Earth. But nothing like this has ever been seen on a natural satellite. These auroras are caused by the interaction of magnetic fields and solar radiation. But on Ganymede, the interaction between its magnetosphere and plasma from Jupiter generates an Earth-like laser. Observation of Ganymede's aurora through the Hubble telescope. Scientists have discovered that the mindset of lasers may be influenced by their internal components. Certain metals melted in huge liquid waters. This raises the question of whether there is an unknown internal ocean. This problem has motivated NASA engineers to begin designing a probe to find out once and for all whether Ganymede contains water. And on that mission was the Calvary probe. It was launched on October 18, 1989. After a 6-year journey, it finally reached Jupiter on December 7, 1995. In the course of space exploration, previous probes such as Voyager and Pioneer have succeeded in reaching the new destination in a relatively short time. However, adding interest to the probe due to its weight of 2,559 kilograms, far more than Voyager's 726 kilograms and Pioneer's 254 kilograms. Facing greater challenges. An increase in weight means a slight decrease. There are 2 possible paths. increase fuel to shorten journey time, or take longer trips to save fuel. Since the Galileo was not carrying a large amount of fuel, this is the norm for space exploration missions. Because the more fuel you carry, the heavier the total weight of the leveler, and that makes it harder to get there. The trace fuel he carries is mainly used for adjustment actions when executing active goals. If engineers choose to use these fuels to speed up, then the interest rate increase will not be able to make the necessary adjustments after reaching the destination. This is undoubtedly a waste of resources. In the solar system, Ganymede is thought to be the largest body of water. Data given to Voyager and Pioneer in the 1970s. NASA scientists first proposed the hypothesis that Ganymede could have a huge ocean. This ocean is wrapped in 2 layers of nails, so it's just below the surface. The other level is located on a deeper rocky floor. The Calvary probe reached Jupiter and flew 3 feet past the planet. The images it captured revealed the instability of the aurora. This is consistent with models where scientists expect an ocean to exist inside Ganymede. Combined with observations from the Hubble Space Telescope, scientists theorize that beneath the surface of Ganymede lies a vast ocean of salt water. This ocean affects the satellite's magnetic field, and that affects the performance of the aurora. A 2014 analysis further investigated the thermodynamic properties of water and the role of salts. The results suggest that Ganymede may have multiple ocean layers separated by different refrigerators. All these hairstyles point to a surprising fact. The amount of water inside Ganymede could exceed that of all the oceans on Earth combined. It could be the largest ocean of liquid water in the solar system. This discovery not only offers new hope for the search for extraterrestrial life, it also provides precious resources for unsustainable space exploration. The establishment of a future colony on Jupiter's largest moon has begun. The possibility is nonetheless. The scientific community remains skeptical about whether the remaining inland seas are habitable. Think that even if these oceans are completely liquid, their salinity and temperature may be too high, unsuitable for any form of life on Earth. However, some scientists speculate that, under certain conditions, the connotation of Mu Wason may be much colder than expected. If the temperature can rise, then the existence of life becomes possible. Some possible heat sources include water from a human core, plus volcanic activity. These activities provide an infestation on Earth by seafloor life. In addition, the tidal forces exerted by the giant Jupiter may also be a factor in the warmth of the inner sea. If Jupiter's attractive forces stretch and compress Ganymede as it completes its orbital motion, that's enough energy to warm the inland seas. This could provide a habitable environment for life. Sending probes to Jupiter is currently a challenge, but not impossible. We have successfully completed such a task. However, our understanding of Io is still in its relatively early stages, mainly because the missions of the past few decades have mainly focused on the behavior itself rather than its satellites. The current Everest mission orbiting Jupiter has captured some images as close as 30. Provides us with valuable information about its poles and surfaces. So far, no space mission has yet been sent into orbit around Ganymede, let alone land on its surface. The Jupiter Soldier Satellite Explorer Jose mission was launched by the European Space Agency ESA Successfully launched from the French Guiana Space Center on April 14, 2023, it is an ambitious space exploration mission. It is expected to be launched 9 years later, the first flyby of Ganymede in 2031. It then enters its orbit in 2032. The extended journey of this mission is due to the weight of the pillars reaching 6,070 kilograms. It became one of the final spacecraft in history to be used for planetary research. In order to meet this weight challenge, the mission planned a trajectory involving multiple gravity-assisted maneuvers. These maneuvers take advantage of the Earth, Venus, Jupiter, and some of its other moons, the attractive forces of Callisto and Europa. The main goal of this mission is to conduct an in-depth study of Ganymede, assessing the potential of this satellite to carry life, as scientists confirm the existence of an ocean beneath the surface of Ganymede. This mission will explore the structure of this ocean, temperature, chemical composition, and whether it has the conditions for life. February 2034. When the JUS probe runs out of fuel, he will perform a redirect operation. Direct impact on the surface of Ganymede. This process can only continue to study Ganymede until the very last moment. At the same time, understand the formation process of its stratigraphic structure and thin atmosphere. Ever since humans began exploring the outer solar system and the moons of Jupiter, we are constantly learning new things. There is also a growing interest in these massive celestial bodies. However, reaching these distant places from Earth remains a major challenge for space agencies. Could this mission be the key to eventually finding signs of life on Ganymede? Still full of unknowns and expectations, this fascinating startup mission that arrived at its destination 9 years later, it undoubtedly provides us with a valuable opportunity to explore the world of the three tombs. Let's wait and see what amazing discoveries this mission will reveal. Years ago, the Hubble Space Telescope revolutionized physics. It's just that no one noticed it at the time. Named after the most successful space telescope, astronomer Ed B. Hubble brought us a new perspective on the universe and put forward many theories about the origin of the universe. 100 years before the launch of the telescope named after him, his theory of the expansion of the universe has been called into question. In 1929, Hubble proposed the theory of the expansion of the universe. In the 1920s, astronomy has undergone a revolution. The first improved telescopes enable people to observe the universe more deeply. Edwin Hubble was one of the first researchers to realize that the Milky Way is not the only galaxy. Astronomers at that time opened up a whole new dimension of the universe. The Milky Way is just one of billions of galaxies. The true scale of the universe is gradually emerging. Before this revolution, you get a small radius. It's almost impossible to see beyond the galaxy. However, this is a lot more advanced than a few years ago, when people didn't even know about the existence of the Milky Way. And here we are again. Edwin Hubble was one of those scientists who was too open to the new dance floor. He was amazed by the multitude of newly discovered galaxies. He observed distant galaxies significantly farther away from Earth. This observation laid the foundation for Hubble's constant, and the velocities of distant stars are proportional to their distance from the Earth. This finding lends support to the theory of the expansion of the universe. Hubble used the brand new 2.54-meter Huco Lookout Garden at the Mount Wilson Observatory, measuring the redometer in the spectrum of galaxies, and determine their distance. These findings influenced Georges Ouimet in Belgium. He hypothesized that the universe originated from a single point. In 1929, Hubble published the results of his study of the red meter and the velocities of galaxies. Soon after, Fermat published the Big Bang theory. For a long time, these two models form the foundation of modern cosmology, and they're still valid today. But it's no longer reliable. The Hubble telescope overturned its namesake. It is precisely this space telescope named after Hubble. For the first time, a major challenge was raised to the Haber regular book. In the late 1990s, the Hubble telescope observed some phenomena, disproves Edwin Haber's calculations. The launch of the Hubble telescope in 1990 was a revolution. It allows us for the first time to remain undisturbed by the Earth's atmosphere. Look deep into the depths of the universe. Hubble telescope reveals stunning findings for the first time, such as the existence of supermassive black holes at the centers of many galaxies, the diversity and beauty of nebulae and the birthplaces of stars. By observing the brightness that benefits deformation in Ia-type Korea, found strange differences in Hubble's long tree. Measurements of the brightness of these events offer an alternative way to determine cosmic distances. These measurements led the researchers to arrive at a different rate of expansion of the universe than the Hubble method. Benefit variable stars are stars with a specific relationship between luminosity and pulsating period. Type I supernovae are white dwarfs that explode in binary systems. These supernovae act as standard candles because their absolute brightness is known. By comparing their observed brightness with their actual brightness, distance can be determined to determine the expansion rate of the universe, and this is where the results differ from those of the Edwin Hubble method. Later, the Planck satellite confirmed these disturbing observations by measuring the cosmic microwave background radiation. This radiation is left over from the Big Bang. Today we call these measured differences Hubble tensions. The tension is created because of the Hubble constant, measured by cosmic events based on local brightness, consistently higher than the value derived from background radiation data. This discrepancy is the first sign that our physics is coming to an end. Means a new physics beyond the standard model. This difference in measurement of the expansion rate of the universe may open a window to an entirely new kind of physics. This new physics could go far beyond the standard model of cosmology and astrophysics as we know it. But let's start with the world of microscopic particles. The standard model of particle physics is a description of theoretical construction of the basic components of matter and their interactions. This construction can often be successfully applied to the experimental results of large-scale matter phenomena. However, in the case of the Hubble tension, it doesn't work. This further indicates that Hubble tension is not just a measurement error. Many scientists believe it must be the solution to an unknown physical composition. We have made great achievements in the study of subatomic particles. These particles form the foundation of the universe, but our knowledge of them is still limited. We know that quantum florals and wave sieves, but the interactions and behaviors of many of these examples remain mysterious. Researchers continue to find more examples. Some examples of behavior are so mysterious, so much so that our current fundamental force model cannot explain their effects. Many particle physicists believe these launches in the subdomain point to an unknown fifth fundamental force. So far, we base our entire worldview in physics on four fundamental attractive forces: electromagnetic force, strong some and weak some. Maybe our knowledge is incomplete. But what effect do these particle physics processes have on the Hubble tension? And the answer is quite simple. This psychology may work on a cosmic scale, affects the expansion rate of the universe. Until now, the mysterious dark energy has long been thought to be responsible for the accelerating expansion of the universe. There may be examples that have not yet been discovered. They interact with dark energy and influence their behavior at different scales. It is also possible that dark energy is not constant as previously assumed. It changes over time. Perhaps dark energy is even more dynamic than we previously thought. His variation could explain the discrepancy in Hubble's Changshu measurements. This also means that other physical quantities in the universe may also change. It's not constant. These new ideas will revolutionize our physical and scientific theories. Every discovery that cannot be explained by traditional models could be an important indicator of new physics. And here comes the new James Webb Space Telescope. His discoveries in the distant past no longer fit standard cosmological models at all. The discovery of the scarf broke the cold dark matter model. Summer of 2002, when the brand new scarf telescope first opened, created a glorious moment in the history of space exploration. Based on infrared technology, this telescope sees better than the Hubble telescope. Astronomers are eagerly awaiting the launch of the new telescope because he has the ability to go back to the time when the first stars were born in the universe. What scientists saw was a shock. The first liftoff images of the scarf show no sign of those massive round transverse stars or the original chaotic dwarf galaxies. Instead, the scarf shows a vast array of perfect, very bright galaxies. When the universe was supposed to be completely dark, galaxies such as Glossy 13 or Massey exist between 2 and 300 million years after the Big Bang. However, this kind of week should only happen after the Big Bang. The scarf will only appear in more than 30-40 years. We also discovered massive black holes. These black holes are so massive, could hold billions of suns in a young universe where only larger objects are likely to form. These findings are unexplainable. These observations are consistent with those based on general relativity. The cosmic Weibo background radiation contradicts the cold dark matter model of the cosmic large-scale structure. The standard model explains the nature and evolution of the universe through 6 parameters, including dark energy and dark matter. Dark energy is accelerating the expansion of the universe, and the dark matter is driving structure. The only problem is that, so far there is no evidence of dark matter or dark energy. They are purely theoretical corpses. There is growing evidence that Edwin Bowe's theory of the expansion of the universe may be wrong. They should have known that Harbaugh had seen this. The Hubble telescope has discovered the oldest galaxy in the universe, Red Spectre. The value is 10.3. This week is 1320 billion years old. So only about 480 million years after the Big Bang. The standard cosmological model states that the first real week in the universe was about 1 billion years after the Big Bang. Scientists were initially skeptical about the Hubble telescope's discovery this week. Scientists are eagerly awaiting the launch of Weibo in order to observe the universe more deeply and clarify questions about the existence of this ancient novelty. Webb shows scientists what they need to see. The row of galaxies called 13 is older than Hubble's discovery. There might even be a Honey 20 galaxy. If their age is confirmed, this week will be so close to 70 points. So much so that the Big Bang Theory will no longer hold true. Haber issues another warning ahead of Weibo launch. March 202, American John. Hopkins scientists have confirmed the discovery of the oldest single-family star ever observed. They named this extraordinary discovery Chen-Xing Elda. Only about 900 million years after the Big Bang, he may have been one of the first stars. Because of new discoveries, shows that billions of stars in many developed galaxies existed before Elda.